Let's take a look at the Chapter 9 quiz. It hadn't been opened, so nobody had taken a look at it. I'm going to take a look at it with you. All right, so let's take a look. Which of the following statements are true? More than one are true. Is an array a variable that can store multiple values of the same type? Yeah, that's right. You can have an array of names, right? And it's just one variable name, but it can have a whole bunch of names in it, right? A whole bunch of strings. So that looks true. Arrays are declared using that operator. Yeah, that's absolutely true, because how do we declare our arrays? Like this, right? Int x equals new int 3, right? Like that, to make an array of 3 integers. And of course, you don't need to space it out like that, right? Or you can declare an array like this. And it would put those numbers into an array that was of length 1, 2, 3, 4, 5. Oh, I better give it a different name, huh? So anyways, that looks like a true statement. Once you allocate an array, will its size grow and shrink to hold additional data? Absolutely not. Once you declare this array right here, it's always going to be 3 long. If you want to expand it, you have to allocate a new array and then copy all the old elements into it. And then if you declare an array of ints, you can store strings or doubles in it. No, that's definitely not true. If it's an array of ints, all you can put into it are ints. Question 2. Write a line of code that will declare an array of type int. The array should be named tests, right? So int, square braces, tests. And it says don't make it actually allocate the array, just declare it. So that now we have declared it. Now write a line of code that will declare and allocate an array, should be an, not a, of type int. It should be called tests and allocated to a length of 5 elements. So we will need the new keyword. Like that. All right, let's write a line of code that will declare an array of type string. It should be called colors. And we're going to use an initializer list this time. So in the initializer list, we need our colons. And honestly, we could just copy this and paste it, right? I won't tell anybody if you don't. There we go. And don't forget the space at the end of the semicolon at the end of the statement. There we go. True or false? Would this create an array of 5 elements? It absolutely will, right? Because it's got an initializer list. 1, 2, 3, 4, 5. Definitely a true statement. Which of the following would print the first element of the array? Well, if that's our array, we know its name, we know its size. Since it's got a size of 10, we can access elements 0 through 9. Element 0 would be the first one. Array 7. Which of the following statements would print the last one? Okay, so since its name is scores and its length is 10, then the last one would be 9. What's a good way of calculating the number of elements in an array? Well, if you wanted the length of a string, you always had to put the parentheses. But length is a property, it's not a method of the array class, so you just choose that, right? Scores.length. If you have this array, which of the following would be a good way to print the array? Well, if you have this array here, there's more than one way to do it, right? Let's go think it out. You can use a for loop for int I equals 0, I is less than num, I plus plus, system.out.println IA at that specific value. And ooh, look at that. Prof made a mistake. There's no such keyword as const in this language. It's final. All right, so anyways, you print out the array at that specific element. Now, I'm not sure if I chose I or a different index counter. Yep, I think I did. Okay, so I is equal to 0, I is less than num, print I. No, that would just print out 1, 2, 3, 4, 5, 6, right? I is equal to 0, I is less than num, I plus plus, print out IA. No, that would just print an array reference out over and over. We need IA subscript I. There we go. No, still don't have IA subscript I. Here we go, right there. IA subscript I. For int I is equal to 0, I is less than num, I plus plus, subscript I. And normally I would just replace this with IA.length. All right, and then there's the for each syntax. For each syntax looks like this. For int x colon IA, for every value x in for every value x in the IA array, for int x colon IA, system.out.println x. That's the other way. X is already defined. Okay, fine. Well, that's because of that statement. I'm going to delete those 2 lines. Alrighty. So we need not this one, for every x in IA, print out IA at subscript x. No, that's a bad idea, right? Because x actually already has the array elements in it. So it's that one. Those are the 2 that are correct. Which of the following statements are true about parallel arrays? Well, that's the last lecture I need to record. I will get that one done for you today. Which of the following statements are true? 3 are true. Parallel arrays are 2 or more arrays that contain related data. That is absolutely true. To use parallel arrays, elements of the same subscript are related to each other. That is true. They can be of different types. Yeah, that's absolutely true. That's the entire point of parallel arrays. And parallel arrays should be of different lengths? No, they have to be the same length. The definition of a parallel array is 2 or more arrays of the same length where the items are linked by their subscript, their index number. So for example, you could have an array of names, first names, right? Bob, John, and Roy, right? And then you could have another array of last names. L names is equal to, all right, we got Dylan, and we got Lennon, and we got Rogers, Roy Rogers. There we go. Right. So F name subscript 0 is Bob, L name subscript 0 is Dylan, F name subscript 1 is John, L name subscript 1 is Lennon, F name subscript 2 is Roy, L name subscript 2 is Rogers. If it is unknown how much data an array will hold, you can wind up using a partially filled array. I'll mention this in my lecture, which is one where not every array contains valid data. And if that's the case, if not every element contains valid data, then you have to have a counter, right? Because you may have 100 100 homework scores to grade, but you've only graded the first 3, then you have a counter, right? Set to 3 so that you know not to use 4 through the rest of them. Which of these statements are true about partially filled arrays? You better make the array large enough to hold the largest expected number of elements, right? Use a counter variable to keep track of the number of items stored in the array. That's true as well. And we've already found the 2 are true. The third one, when you process the array, always go from beginning to end, ignoring the counter variable. No, that's why you have a counter variable, is so that you know when to stop if it's only partially filled. Which of these are true? To compare two arrays, you must compare element by element. Well, that's true, although you can call a method to do it, but that's what it's doing. A loop is a good way to compare arrays. Yeah, that's true. A two-dimensional array is a grid, right? Like a tic-tac-toe board is a 3x3 array. And so a 4x3 array, does it have 7 elements? No, that'd be like if it had 4 rows and 3 columns in an Excel spreadsheet. Does it only have 7 elements? No, it has 12. A nested loop is not a valid way to access a two-dimensional array. It really is the only way. Well, I shouldn't say that universally, but yeah, that's how you access a two-dimensional array. And so that's a topic for today's lecture. And to see if two arrays contain the same series of elements, you use equal. Absolutely not. Absolutely not. Instead, you need to step through them item by item to compare them. So when you allocate an array of ints in Java, the elements will be initialized to 0, and that's true. If you've taken C++, you probably know that that's not the case in C++ unless you do something specific. True or false? When you allocate an array of reference types, such as strings, they're initialized to null. That is also true. All right. So that's pretty much it. That's the answers to that one. So the last lecture will be coming today, and not going to be any homework attached to it because it's too late in the semester. But I did want you to know the answers to this quiz, and I do want you to take the quiz, right? But you ought to get a perfect grade. Okie doke. By the way, y'all are an excellent class, and I really, really would like to see you in Advanced Java in the fall. This class has been a really good class. It's had a higher level of participation despite the troubles this semester than a lot of my other classes have. So good going, y'all.